Right, the second question is using the same system at the start, but this time it is going to be at a different temperature. And that's important because temperature sets up your um, K value. So the different temperature gave us a different K value. Okay, so it's still the same reaction, it's still the same starting pressures. So calculate the reaction quotient and which direction will this reaction shift to reach equilibrium. Uh, the reaction quotient obviously does not change, right? Because the initial pressures didn't change, so the reaction quotient is the same number as it was in the first problem. However, now we have a different answer about what direction everything will shift, because now we have a Q that is greater than K. So I'm still following the same format. I have my first answer, what direction will it shift? And that's this part over here, right? It'll shift to the left. Then I have my explanation. I mention my Q versus K, and then I mention how it has to do something, what it has to do with its products and its reactants, so that it becomes totally clear that I understand what it means when I start with these pressures and how I'm going to get to equilibrium. So that'll get me my first point. Uh, Typically this one here, actually this should probably be worth, this would be worth 2 points, one for the direction and one for the explanation. Once I have that, I'm ready to figure out the equilibrium pressure of each gas. So just as before, I would set up an ice table, but notice this here, look, because we are shifting to the left, now the reactants are plus, not minus, and the products are minus. So while the ratios are the same, 1 to 1 to 2, it's this one that is reducing, and these two that are increasing. So you have to stay totally aware of what direction things are shifting, which is why we come up with Q in the first place, to find out, do we shift to the left or do we shift to the right in order to get to equilibrium. Once again, now it's just math work. So I plug in my numbers. Notice I've got my new K value here. It's still a perfect square. So I follow the same sequence. Take the square of both sides. That reduces my complexity. There will be no x squared term, and I don't have to use a quadratic. And as long as I can manage to do the math right, I find the value of x, in this case, and then I plug the value of x into my relationship, keeping in mind that now it's plus for the reactants and minus 2 times x for the products. So here I have my answer. There's the second point, right? The point of the reason I set up a problem like this is because you can see that just because K is positive doesn't mean you automatically know which direction the reaction is going to shift. It depends on the initial concentrations and the value of Q. So even though K was positive in both number 1 and number 2, that does not mean that we're going to automatically know which direction the reaction will shift.